These ODEs are all separable. Let's solve them. dy dx equals negative 4xy squared. So I'm going to move all the x's to the right and the y's to the left, and I'm going to have y to the negative 2 dy equals negative 4x dx. Integrate both sides. The antiderivative of y to the negative 2 is negative y to the negative 1. There's technically a plus c there, but I'm going to smush it into the plus c that I put on the right. So then I have negative 2x squared plus an arbitrary constant c. Okay, I'm going to multiply both sides by negative 1. So I get y to the negative 1, which maybe I'm just going to write as 1 over y. 1 over y is positive 2x squared. Technically, this is minus c, but because c is an arbitrary constant, I'm just going to keep writing plus c here. Now I'm going to take the reciprocal of both sides, so I get y equals 1 over 2x squared plus c. There is my general solution. And then part B just is asking me to solve the same differential equation with an initial condition, that y of 0 equals 1. So y of 0, that means plug a 0 in for all my x's. So I get 1 over 2 times 0 squared plus c has to equal 1. So 1 over c has to equal 1, which means c is 1. It's super tempting to circle that and say it's your answer because you've been so trained to solve for an unknown. But the answer is the function with the c value replaced. So it's going to be y equals 1 over 2x squared plus 1. Okay, y prime equals 3e to the y x squared. So hint, replace the y prime with a dy dx. 3e to the y x squared. So I'm going to put all my x's on the right and my y's on the left. So I'm going to divide both sides by e to the y here. Same thing as multiplying by 1 over e to the y. And I'm going to multiply both sides by dx. So these cancel, and I get 3x squared dx when I multiply by dx. And 1 over e to the y is the same thing as e to the negative y dy. And then I'm going to integrate both sides. The antiderivative of e to the negative y is negative e to the negative y. Technically, there's a plus c there, but I'm just only going to put it on the right. So I have x cubed plus c. And now I need to get the y by itself. I need to solve for y. So I'm going to multiply both sides by negative 1. So I have e to the negative y equals negative x cubed. Technically, it's minus c, but c is an arbitrary constant. So I'm just going to write plus. I'm going to take the ln of both sides. So I get negative y equals the ln of negative x cubed plus c. And then I'm going to multiply both sides by negative 1. Y equals negative the ln of negative x cubed plus c. Okay, part D. Again, y prime is the same thing as dy dx. So this is dy dx over 2x equals the square root of 1 minus y squared. So dy dx divided by 2x, that's the same thing as dy dx. It's just a complex fraction. Dy dx is my numerator. Instead of dividing by 2x, I'm going to multiply by 1 over 2x, multiply by the reciprocal. Which means that I can multiply both sides of this equation by 2x dx. So I get dy equals the square root of 1 minus y squared times 2x dx. Then I'm going to move that square root over by just dividing by it. So I have 1 over the square root of 1 minus y squared dy equals 2x dx. And integrate both sides. The antiderivative of 2x is x squared plus c. And the antiderivative of 1 over 1 minus y squared is arcsine. That is one of the antiderivatives you have supposedly memorized. All right, so my next goal is to get the y by itself. So I have the inverse sine of y. To undo that, I'm going to take the sine. So take the sine of both sides. The sine of the inverse sine of y is equal to the sine of x squared plus c. And y equals the sine of x squared plus c. Okay, x, y prime equals the ln of x, where y of 1 equals -2. And there's a hint about taking the plus or minus square root, so we will just like sort of hold that to the side, and maybe it will make sense when we get to the end here. Okay, so x, y prime equals ln x. Rewrite the y prime as dy dx. So I have x, y times dy dx equals the ln of x. I want all my y's on one side. That is already done. I have y and a dy on the left. I want to move my x's over. So I'm going to have to divide by x and multiply by dx. So I have y dy equals the ln of x over x dx. And then I'm going to integrate both sides. The antiderivative of y is y squared over 2. Technically, there's a plus c there, but I'm just going to subtract it from both sides anyway and smush it in with the right-hand side's plus c. Okay, the antiderivative of ln x over x. This is a U-substitution problem. The reason that you would know to use U-substitution is because the ln of x and its derivative, 1 over x, show up in the integrand. So that is always a key indicator that a U-substitution will work. So if we let u be ln x, then du dx is 1 over x, which means that dx is x times du. And then we're going to plug into the integral. This becomes the integral of u over x. Replace the ln x with a u, copy the x, and then dx is x times du, and the x's cancel. So I have y squared over 2 is equal to the integral of u du, and the antiderivative of u is u squared over 2 plus c. And then replace the u with what we let it equal up here, which was ln x. So y squared over 2 equals the ln of x squared over 2 plus c. And now I need to try to get y by itself. So I'm going to multiply both sides by 2. So I get y squared equals the ln of x squared plus 2 times c, which is just a new arbitrary constant. We'll keep calling it c. And then I'm going to take the square root of both sides. Okay, that's where my hint was talking about. It was talking about the square root of both sides. We'll need to do the positive or the negative. Oh, right, when you take a square root, you need a positive. So square root both sides, I get y equals plus or minus the square root of the ln of x squared plus c. So the plus or minus means that this isn't a function. So I have to decide, is it the plus or is it the minus? And it says to use the initial condition to figure it out. So my initial condition is that y of 1 has to equal -2. So let's see, y of 1, that would be plus or minus the square root of the ln of 1 squared plus c. It's supposed to equal -2. Okay, it must be the negative square root then. I need the negative of a square root to equal -2. So it's got to be negative. And the ln of 1 is 0. So this is negative the square root of c is supposed to equal -2, which means that c has to be 4, right? So this says that square root of c has to equal 2, which means that c has to equal 4. So my final answer is this function, where now I know that I'm supposed to use the negative square root, and I know what c is. So I'm going to rewrite that formula with just a negative square root, and the value of c is 4. So I get, let's see, y equals negative square root of the ln of x squared plus 4. Okay, and these ones you don't have to isolate y after we solve the differential equation. So we're just going to separate variables, integrate both sides, and then we're done. Okay, so I have 4y plus cosine y dy. That's all my y's on the left, and then get my x's on the right, so I have 3x squared dx. Integrate both sides. Antiderivative of 4y is 2y squared. The antiderivative of cosine y, copied that wrong, it's supposed to be minus cosine y. So the antiderivative of cosine is sine, so this is minus sine y, plus c, which I'm just going to move to the other side. Antiderivative of 3x squared is x cubed plus c. And that's it. That's all I'm going to do. I don't need to isolate the y once I've taken the antiderivative. Okay, and then in part G, it's the same differential equation, just with an initial condition this time, that y of -2 equals 0. So -2, that's an x value. 0, that's the y value. So I'm going to plug in everywhere I see a y, put a 0. Everywhere you see an x, put a -2. So 2 times 0 squared minus the sine of 0 equals -2 cubed plus c. The sine of 0 is 0, so I get 0 equals -8 plus c. So c is 8. Tempting to circle that and say that's the answer, but the actual answer is this function, but replacing the c with an 8. So we get 2y squared minus the sine of y equals x cubed plus 8.